Hello, good day, everyone. Welcome to my class, Maths with Victor. Please kindly subscribe to my YouTube channel so that you can enjoy my maths content, amazing mathematics content. Also, like, follow, share my Facebook page to all your friends and to all high school students so that you can enjoy my content as well. Welcome. So today we want to look at equations in irrational forms. Equations in irrational forms. And the first point I want you to note very clearly is that in any mathematical equation, there is always the presence of an unknown denoted by any letter of the alphabet. And to solve an equation means we are looking for the numerical value of the unknown. This means that we want to find out which letter, which number the letter is representing. So for what we have here, we have square root of x squared minus 7 equal to 3. So we are looking out for the number that x is representing so that this mathematical statement becomes true. So how do we solve for x? How do we look out for x? We need to eliminate everything here so that we are left with x at the end of the day. So we start by eliminating the square root. But the biggest question, how do we eliminate square roots? In mathematics, to eliminate square roots, we look for the inverse operation of square roots. And the inverse operation of square roots is the square, which means squares eliminate square root. The converse is still correct. Square roots eliminate squares. Just like the cubes and the cube root, the raised to power 4 and the fourth root, the raised to power 5 and the fifth root, and so on and so forth. So to eliminate this square root, I will start off by squaring this quantity so that this square eliminates this square root. But there's something very important I want you to note. In any equation, we are always comparing two things. First, at the left-hand side, then at the right-hand side. And we are saying that this quantity is equal to this quantity here. So while solving an equation, there is always a need to maintain equality. For instance, I have two markers here, and I say that this marker is equal to this marker in size or in weight or in height, whatever. That is true. And then all of a sudden, from nowhere, I introduce something else to this marker. Possibly, I added 10 to it. The moment I add 10 to this marker, they are no longer equal. Because what I introduced here, I did not introduce here. But that is wrong. Because if I want to maintain equality, whatever I do to this one, I will do to this. So if I add 10, they are still equal. If I remove 20, they are still equal. If I divide by 2, they are still equal. So the moment I introduce something that was not there originally, square, to the left-hand side, I must also introduce it to the right-hand side so that the equation remains balanced. That is very good to note. So we call that to square both sides of the equation. Where we needed to square originally was the left-hand side, but to maintain balance, we must also square the right-hand side. So at this point now, on this square, we eliminate the square root, and we are left with x squared minus 7 equal to 3 squared is equal to 9. Please note very well that 3 squared means 3 times 3. You multiply 3 by itself in two places. A lot of times people mistake 3 squared to be 3 times 2. That is very wrong. So 3 squared gives us 9, and we are here right now. So what do we do again? We are looking for x, remember. So we need to eliminate minus 7 by taking it away from here to the other side of the equation. That's what we call collecting the like terms, because 9 and minus 7 are numbers. So move all the numbers to one side of the equal sign. And mind you very clearly, or note very clearly, that anytime a quantity moves from one side of an equation to the other side, the sign of the quantity changes from minus to plus, from plus to minus, as the case may be. So we have minus 7. I'm going to move it away from here. S squared remains S squared. It didn't move anywhere. It's equal to 9 was at the right-hand side. It remains 9 at the right-hand side. It didn't move anywhere. So minus 7 moves from the left-hand side to the right-hand side. It changes to plus 7. Very important. Minus changes to plus. If it was plus, it changed to minus. So we can simplify this further to have s squared is equal to 9 plus 7 is what? 16. But mind you, we are looking for x, not x squared. So the next question, how do we eliminate square? Like I explained here, the inverse is square root. So you square root here, but you must also square root here. So this square root eliminates this square. We are left with what? X is equal to, what is square root of 16? Square root of 16 is plus or minus 4. That means the x here as a variable is representing either plus 4 or minus 4. And whenever you are done solving any equation, you can always check whether you are right or wrong by going back to the original equation, which was square root of x squared minus 7 equal to 3. When we go back to the original problem, we remove x and replace with the value we got. Remember, we got two answers, plus 4, minus 4. So to check whether we are right or wrong, we replace x with plus 4. When we do that, plus 4 squared means 4 times 4, that is 16. 16 minus 7, that is 9. And square root of 9 is 3. That means plus 4 is correct. We can also check for minus 4. Minus 4 squared means minus 4 times minus 4, which is still 16. 16 minus 7, 9. Square root of 9, 3. Minus 4 is still correct. So to solve this equation, the answer is either plus 4 or minus 4.